Hello and welcome back to Arise.Works. This is the workshop on attributes and VOPs inside of Houdini episode 10, where we will discuss how to work with noises inside of attribute VOP. And in our case, we will find a way how to generate infinite amounts of different boulders just out of a subdivided sphere. And if you can see, if we tweak it a little bit, it doesn't really matter because, well, since we are really working with attribute VOPs, we generate infinite amounts of this kind of boulder looking geometry without actually, without touching any vertex by hand. So let's get started and let's see and let's find out how we did that. And as per usual, we will start with nothing but, nothing but environments, lights and grid, and actually I will disable both of those. Give me a sec. Okay, so we got nothing except for geometry, and even that we delete and create again just because we start from the very beginning as per usual. So next up we drop the attribute VOP, and attribute VOP will be run over points. We will run it over points because we will utilize the displace along normal node to move the points around. Displace along normal will not work with vertices, with faces, with nothing else. So keep that into the points. All right, so let's see what we got. If we create a constant, right, and we copy the constant into the amounts, and we connect the displaced P, as in displaced position, into position, let's see what we got. So essentially what we are doing is we are growing geometry against the normals of said geometry. Simple as that. However, if we add some noise instead of just constant, you will immediately see that we will have various results. So if you just type noise and say, I don't know, turbulent noise, connect the P4 position so that noise knows where does it should generate the values. And let's just, for sake of visualization, connect the noise to CD for colorization so that we will know how much displacement we will actually see. But in our case, actually displacement is more obvious than not. It's like previously we worked with some attributes, but this time around we're just displacing the positions of the points. Anyway, so as you can see, it's a bit low res, so I suggest we subdivide it a number of times. Just don't go truly overboard with this. And as you can see, we indeed have some kind of effect going on. Now, the reason why I chose sphere for this exercise, because if we choose the box and we subdivide the box, actually if you just subdivide the box, you will see that it sort of becomes sphere. So in our case, we'll do the polygon mesh with axis divisions, I don't know, like 8. So if we do the attribute VOP on that one, when you start to move points around, as you can see, what previously was the edge of our box, just because the amount of topology is the very same as the amount of topology on our faces, the displacement will look kind of strange. As you can see, it really pushes out those edges. It doesn't look particularly fantastic. There are ways to combat this situation, but in our case, we will just stick to spheres for the time being. And we will talk a little bit about how to fix those weirdnesses. Okay, so displacements. If we tweak the scale, obviously that's what it says. Tweaks the scale of displacement. So what can we do? How can we actually create the kind of boulder type looking geometry setup that will generate our rocks, alien rocks, and everything in between? So I just happen to know that whirly noise, when it's set to Euclidean, we connect the position to position and we get the distance to the amounts. As you can see, it is already creates this effect of kind of chiseled look. However, there are other ways you can manipulate the noises. Let's actually talk about noise manipulation. So you can control the position, frequency, and the offset. So I'll just increase the subdivision a little bit once more so we have more geometry to work with. Okay. So position. Let's say we have a sine and we get the position into the sine and the result will be position. So what it does is it converts every single position, gets into the sine function, and gets it into position. You can already see that we manipulated it somehow. And also, we can actually multiply by a constant, this amount, and the multiplier, let's say, something like this. So as you can see, before we fed the position into whirly noise and before we fed it into the sine function, we can already do interesting things. For example, just multiplying the geometry. So we are kind of like confusing the noise into thinking that this is the actual position. However, we do a lot of interesting things with it in before. All right, so let's just delete this for a second to keep it a little bit more clear. Next up, I'll add a turbulent noise, and we will connect the position into position. However, the noise, the 3D noise, will be fed into the position of whirling noise. And as you can immediately see, this gives us some really interesting results. So essentially, the whirling noise, it retains its kind of structure, but since we fed the noise into the position, it obeys the noise. It's like it obeys the how the noise that we input in the position looks like, but it retains the texture of itself. Okay, so if we let's say original Perlin noise. So as you can see, it retains this chisel look, but chisels go along the noise that's being dictated by the turbulence noise. Obviously, it would increase the roughness, it becomes a little bit more distorted, and it loses its kind of definition. However, as you can see, it does indeed give us really interesting results. As a matter of fact, if we get position back into the position, but this turbulent noise will be controlling the offset, and offset will be just making the noise swim through our geometry. If we feed that into the offset, we will immediately see that we have sort of this kind of result. And by the way, you can not just control the roughness. If you like this roughness, you can just increase or decrease the amplitude. So it gives us kind of different results. And the turbulence is the complexity of noise. So you can move it up and down. Okay, with that out of the way, what else can we do? Now, I will just delete this for a second. And let's see. If we create another woolly noise, but this time we will subtract distance 2. And by the way, distance 2 looks like this. Distance 1 looks like this. However, if we subtract distance 1 out of distance 2, it will look like this. Gives you kind of interesting-ish result, but doesn't really look like much. So what we're going to do is we will actually feed the amount into the displacement as per previously, but then we will multiply by a constant so it doesn't have this drastic effect on our geometry. And then we will add this noise to this noise. And now we can just scale the effect of our second input. So I would say we increase the frequency quite a bit, maybe offset it a little bit. It doesn't really matter. And now that you can control this kind of like another effect of being it a little bit more chiseled. Now, interestingly enough, if we negate this result and add it, it will actually subtract. So we will have this kind of effect. If you like it like this a bit more, you know, all the power to you. But in my case, I think we will stick with this representation of the noise. Okay, so what else? Let's say finally we get back to our turbulent noise. We can add the noise just to our results and multiply it. Again, multiply by constants, so we don't have to input the second constant, just so it, you know, it's a bit easier to set up, a bit quicker. So as you can see, if we increase the turbulence, the alligator noise does its magic, and it kind of, we almost have this look that I was going for. And as a matter of fact, I think we'll create another turbulent noise copy. And I think we go, doesn't really matter actually, but what I want to do is I want to offset the initial generation of the noise so it becomes a little bit more, let me see. Okay. Let me see without it. Okay, I'm not sure. Oh, right. We have to go to the 3D noise. My bad. Okay, so this is the result. I think it's actually what we were going for. I would even suggest that's a little bit better. So next up, I think we subdivide it once more from 4 to 5, so we have even more geometry to work with. And there you go, we have our boulder setup. And by the way, yes, if you go to sphere and you press like, so the radius of the sphere, the height will be not just 1, but let's say 1.2. Let's see what we have. Unsurprisingly, we have another boulder generated and, you know, looking pretty good. As a final thing, you might have already seen that previously we had some sort of colorization, and obviously it was made with a ramp parameter. And the result of this noise, we will get into the ramp, and then we recolor everything from 0 to 1 in the colors of what we would actually want to have. So we go, actually let's rename it, colors. Go up, and we have our colors, and this one will be like something like this. I'm not sure where. Well, okay, here it is. I didn't see the header of this pop-up menu. Anyway, this will be like brownish, maybe slightly darker, and if my assumptions are correct, actual noise is going on about here. So let's make it green, so to speak. Okay, here we go. This is gonna be, no, it's not gonna be green. I'm just colorizing it just to see what's what. So I think this one could be like this one, this color, but really, really dark. So it's kind of like worn out. This green could be like sandish, but not as sandy. Maybe a little bit more orange. Honestly, I'm not the biggest fan of gradient pick and gradient selection in Houdini. To be completely clear, I think one of the best selections are in the Substance Designer, because you literally can draw across the picture and not fiddle with the, you know, hand painting the thing. Anyway, so let's back to our grid, and there you have it, the setup of boulder setups. And yep, we did not move a single vertex. We can type in different numbers and different results will be generated for us, so we don't actually have to move anything. By the way, if you just move about your your boulder. The boulder again will be regenerated because our noise works on the position. As previously mentioned, or previously you might have already seen or thought, you can promote the frequency, you can promote the offset, you can promote pretty much anything and then control it from here. So like, I don't know, let's say 3, and we have this result, which arguably looks even cooler, to be honest. And yep, there you go. So, final thing, I wanted to talk about how to, let's say, box, and you know what, I'll just copy this sphere because this is fine. So we have this box, we have this sphere, and if we just connect them via the Boolean, so they have shared topology, okay, union. Oh, here we go. Okay, so if we subdivide this, you will see that first of all, it looks kind of weird. And second of all, if we start to attribute WAP this result, well, first of all, the amount of geometry is not the same. So this is like bad-ish setup. So what can we do? We can do voxelize. It's from the mesh. From side effects labs. It actually gets all the geometry and voxelizes it and creates the even topology. So this is really useful. And if we smooth it a little bit, you can see that we indeed have this smooth. So how did we do that by hand? It's actually VDB from polygons. Yep, we fit this Boolean, we go into the VDB from polygons, and then we convert VDB back to polygons. And there you go. And then you can control the voxel size to, create more or less topology. So this is really useful. And if you don't want these sharp corners right here, you can go back to our VDB from polygons, and we can VDB smooth. And we can smoothen out the results. And it will be, well, more smooth, as the name suggests. So let's say 1.5. And there you go. We have geometry that will be working pretty good with our attribute pop setup. And let's actually see. We go to the subdivide. Let's have it subdivided just once. Okay. There you go. I would suggest subdivide it a little bit more and maybe smooth it like 25 times or something to get a little bit more results, and maybe go inside and get to our displacement. We promote the scale. Where is it? Okay, we promote the scale, and you can immediately just get it inside, get it outside. So there you go. This looks pretty cool. This is the effects. I think you will be happy that you will not need to, sculpt boulders by hand, or even you can. Obviously, if you can create something like a boulder, you would imagine if you have geometry that looks like a cave and you run the attribute VOP around this cave, it will be very useful. Again, no sculpting, no moving vertices around by hand. Everything will be just fine, and you will have a realistic-ish looking cave. Now, the final thing I want to talk about is that, if, for example, you have the depth set to 3, so it kind of looks a little bit low res, but you could think about it this way. So you have this sort of base geometry, right? But after that, you can triplanar project displacement maps and actual materials, let's say from Megascans or from Substance or from anywhere else, or in games you just do the triplanar or world align texture, whichever the naming convention it uses. So it actually will not be super heavy on the topology, on the amount of topology, but you can increase the definition. So this will be like the base geometry, and the details will come from normal maps, from displacement maps, from your scans. So again, that would be really useful, but if you don't really need or have any of that, naturally. You can just subdivide it. And then you drop some kind of shader and render it and tweak it to your liking. And that would be the end of this video, I think. So don't, like, in our case, we were just going for this particular look of, you know, let's say another planet, exoplanet rock, but naturally there is a lot of noises. If you just type noise, there is a periodic, anti-aliased, unified, and Voronoi, Wally, blah, blah, blah. A lot of different noises. And some of the noises, as you can see, have even subversions of this noise going on. And naturally, each and one of them have the amplitude, the roughness, the turbulence, and sky's the limit. You can tweak it as much as you like. So anyway, hopefully you liked the video. I hope you learned a little bit more about manipulating noises. You will not be confused by the very fact that we can add noises, multiply noises, even get noises through the sine function. All of this is very much available for you to work within the attribute VOP. So you can create pretty much any intricate setup of your choice and it will be looking just fine. So yeah, if you like what you see, don't forget to hit the like button. If you have comments, suggestions, or just ideas, don't forget to write them in the comment section. And if you don't want to miss anything else, regarding Houdini or anything else like 3D, hit the subscribe button. And I hope to see you in the next video. Thanks for watching. Have a nice day and goodbye.